Okay, we're going to start with the very first section, section one of the unit, sounds and vibrating strings, because it's the first unit, it's the first activity the students get to do. So we're going to go forward and let them do it, let them get their hands on some physics and see what happens here. But before we dive into this first activity, I want to show you a resource I forgot to mention in the first video, the overview I did. Very important resource you should be aware of is this MCAS question search. All right, the Department of Education.mass.edu. There's a MCAS question search feature, and you could go in there and put in your science, technology, engineering, and your introductory physics high school course, and you could go ahead and get questions on all sorts of the physics topics you're going to be covering and basically see what students are going to be tested on. So, very valuable resource. I do recommend that you check that out. All right, let's dive right back in here. So we got our first section here. And honestly, in terms of materials, it's pretty easy for the students to set up, pretty easy to maintain. C-clamps, the weights, the pulleys. The main problem you're going to have is if you're at a school like mine, where we tend to have one set of materials and have to share them among many teachers. After time, these things get lost, okay? This isn't the type of thing where the materials break down. I mean, the C-clamps are metal, the masses are metal. If anything, the string might break, but mostly you're going to find that people are going to misplace some of these materials. So then you're going to be left with, what do I do if I don't have the C-clamps, if I can't find the pulleys, if I can't find the hanger for the masses, what do I do? And an alternative you could use is a very simple way to set up this activity is a string, just any type of thin string you could get anywhere, and some paper cups where you basically puncture a hole in the cup and tie the string, maybe tie it to a paper clip so it doesn't pull through. And they can stretch the string and then pluck it and see how, when they change the tension, how tightly they stretch the string, how does that affect the pitch of sound that they hear, because that is what this lesson is all about. It's all about how changing the string affects the pitch of the sound. Particularly, they're going to be changing the tension in the string, and how does that affect the pitch of the sound. Okay, so if you do this alternative way of doing it, if you don't have the materials on hand, the only thing to know is that when you start the activity and you get to the part, let me just scroll down here, and you get to the part where they actually have to collect data, it's going to be obviously not possible for them to collect good quantitative data if you're using this type, as opposed to the more procedural way of doing it, where you could actually adjust and know the exact mass you're using and the length and so forth. So it's going to become a more qualitative activity rather than a quantitative activity. But actually, I do prefer that for this lesson, and I'll talk about why. What I like to do with this lesson, rather than have them really dive in and start performing the calculations you'll see on the page in the book, the formula they have to use to find the frequency, I feel that my ninth graders, the algebra isn't quite that strong yet to tackle even this sort of basic formula, and they do struggle with that, particularly students with learning disabilities, English language learners. They have some difficulty with performing that. So I try to use a more qualitative experiment, so I don't have that much of a problem if I do have to use this very simple setup. What I emphasize more is the actual experience and what they hear when they change the tension. And I do go through the reading. You do need to go through the reading because it introduces a lot of terms that they need to know. Vibration, variable pitch. What is pitch? They need to know that. So you do need to go through the reading with the students, and it has this nice physics word on the side there. Very good for your ELLs and students that you with maybe learning disabilities that you need to pre-teach the vocab to. A little handy resource. What I recommend also is that you add to this a few terms. I want you to add the term frequency and the term wavelength and define what those mean for students. Because if you approach this in a qualitative fashion, as I recommend. We're going to relate how changing the string, the wavelength of the string, will change the frequency and how that affects the pitch. That's what we're going to focus in on. Now, in order to really bring that home, there's some supplementary materials you'll need, but the good news is they're free. They're found online and it's free. It's on this website called PHET, P-H-E-T. All right, the website right there. And the simulations you want to use while you're doing this activity with your students, after they get to experiment with the string and try different tensions and see what happens to the sound, after you read about pitch and they can now use a vocabulary term to describe what they're hearing, the high versus low pitch, you're going to want to pull up the PHET simulation, the sound simulation. So when you're on PHET, you just go to Play with Sims, and you just go to your physics and sound, and there you have all your simulations. And the sound one right here, when you run that, it pulls up this nice little simulation where you could change the frequency and see what happens to the pitch of the sound. So we'll enable the audio, and you could hear higher frequency, higher pitch, lower frequency, lower pitch, and you even could start introducing the term amplitude with your students and discuss how changing the amplitude affects the loudness of a sound. So I recommend that you work this into your lesson with the students, if even not on that day, that you set aside the next day. Either do it in front of your class, or if you have the resources where students have computers or a computer lab, you can go to a computer lab, and PHET has some lessons that you could print out. If you click on this, there's lessons down there that you could probably print out and have your students go through. So do that simulation, let them experiment with the frequency, the amplitude, see how it changes the pitch of sound. And then I want you to follow that up with the waves on a string simulation, also found on the PHET website. And this is where they're really going to be able to see how when I change the frequency, the higher the frequency, you're going to notice the wavelengths get closer together, and you could pull out a ruler and even measure that. And then if I lower my frequency, you'll notice the wavelengths are now longer. Okay, so this is important. This is back to the standards I first discussed in the first video. It's in the new and old standards, that relationship between frequency and wavelength. So I like to use this first activity as a way to introduce that term of pitch. They're going to need to know that term, especially when we talk about the Doppler effect, either at the end of this unit or the next unit, depending on how you do that. I talked about that a bit in the first video. And as a way to talk about how changing the frequency has an inverse effect on the wavelength and vice versa. So these relationships and these properties of waves and how that affects sound. And a good way to follow up with this, some extensions, is if you have a guitar or stringed instrument, or even better, if you could have a student bring one in. They always love to show off. And you could have them play and change, the string and tighten the string and the tension in the guitar, change where they are putting their fingers on the guitar string, and that will talk about, and then you could talk about how changing the wavelength, how that affected the frequency, affected the pitch. So definitely some great extensions here that you could use with some stringed instruments if you could get one, or just show a video if you don't have one available, or even a reading about it. You could work some reading into how guitar works or a stringed instrument works. So I like to take a more qualitative approach to this lesson, and really get that relationship between frequency and the wavelength, frequency and the pitch in this lesson, and not so much work them on that formula, because again, their math isn't there yet, and they're going to get plenty of practice using formulas as they get to that equation about the speed of a wave. V equals frequency times lambda. They're going to do a ton of equations using a ton of problems using that equation. So I like to save that off to the end and approach this in a more qualitative fashion. What do they hear? What did they do? What was the effect? So that's how I approach this lesson.